Hello everyone. Today we are going to do a Kaggle competition. The competition is CommonLit Readability Prize. What we are going to do is we will give in a text. We will rate its complexity. Let's go through the overview. The question is, can machine learning identify the appropriate reading level of a passage of text? What we're going to do is build algorithm to rate the complexity of reading passages. That's what we're going to do. Let's look at the data. We will be given 3 files: train, test, and sample submission. With the train, we'll have our train files. For test, we will have the test files. Sample submission gives you a format of how the submission file should look like. Let's look at the data itself. ID is ID of the text. URL legal, we don't need it. License, we don't need it. Extract, the passage itself. This will contain the text. Target is what we are trying to predict. Okay, this is the readability score we are trying to find out. Standard error, we don't need it. This is the sample submission, how it will look like. This is the test file. We don't have the target. That's what we're trying to predict. And we have the train. We have URL legal, blah, 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 everything that we discussed. Now let's go to the code and create a new notebook. Let's get started. Let's look at the notebook first. This first cell imports some libraries for us, prints the files that we have. For example, let's run this. It will show us the 3 files we discussed: sample submission, train, and test. And this is the directory that they are located in. This notebook has to be offline, okay, in order to submit. So we go here, we set the notebook options. Accelerator, we will use P100. Don't need this, we don't need this. Internet has to be off. Since internet is off, we will need to load pre-trained models somehow. To do that, we will come here and say add data. We will add the pre-trained transformers. Okay, we will just do add dataset. It will add it for us. As you can see, it is here. Now let's actually get started into the actual implementation. First, let's remove this cell. Okay, we won't need it. Let's start by importing the necessary libraries. We will need pandas. We will need torch. We will need some torch modules such as Optim and NN. From Optim, we will import optimizers. We will import some modules from utils. We will need Dataset. We will need random split to split dataset. And we will need Dataloader. We will need transformers. We will need BERT, Tokenizer, fast. We will need BERT for sequence classification. We will treat this task as a sequence classification, and it will be a regression task. We will need time it to measure the training time. We will import TQDM. Okay. After the libraries have been loaded, let's continue with silencing some warnings from transformers. This is used to silence some warnings. We have to set our device if CUDA is available. Means if we have GPU, we will use CUDA, else we will use CPU. Okay. And we define some hyperparameters. For example, max length. I set the max length as 256. Max length of the model we are going to use, the BERT is 512, but you don't need 512. Okay, the maximum length of the sentence here is around 300 anyways. We will give our model path. This will be the path of our BERT that we imported here. We go up and we go to input, we go to transformers, and we go to BERT, base, and case. Our batch size, I set it to 22. Our learning rate is set to 2a minus 5. Epochs, I set to 2. We did a typo, .set. Okay, now let's read the data. We have train df is pd.read csv. We will go to the input, we will go to the CommonLit readability price train.csv. Let's look at the data. Okay, this is our train data frame. Let's do the same for test. By the way, we can see our files here also. Let's change its name to test, and we will do the same for submission df so that we can see the submission file format. Let's change this to sample submission. Okay, submission df.hat. Okay, let's go through the data briefly. We discussed we will need IDs, we don't need URL, we don't need license. We have the text in extract, so we need it. The target, we are trying to predict standard error, we don't need it. For the test, We don't have the target, that's what we are trying to predict. The submission format will be, we will have IDs and we will have the predicted targets. Since these are done too, let's load our tokenizer and model. We give model path. We do the same for the model. Here we will give number of labels 1. What this means is that we are doing a regression. This is important. We will put the model to CPU or GPU or whatever device it is. We do that by to device. Let's run this. Now we will continue with creating the datasets. We will need 2 dataset classes. One is for training, which will include the target. The second one is for test and submission, which won't include the target. Let's start with the training dataset. Let's name it complexity dataset. Okay, let's give it name of dataset. Our PyTorch dataset will need 3 functions, which is init, where we initialize everything, length, which is the length of the dataset, and getItem, that is to give an index and get the item we are looking for. Let's put init, self, sentences, targets, and tokenizer. These we will receive as parameters. Let's encode our sentences and assign them to the encodings. Tokenizer, we will encode our sentences. We want to do padding to make them an equal size. And we want to do truncation. This will truncate the sentences again to make them an equal length. Truncation equals to true. And we set the max length in hyperparameters. Max length. Okay, and let's give the targets to targets. Okay, this is how we're going to initialize it. Let's go with getItem. We will give self, we will give index. We will have outdate, which what we are going to do is we will take the values and make them tensors. We get the key, we get the tensor, we give value index for key and value in self.encoding.items. We will iterate through the items of the self-encodings we set here. Okay, we have the targets. We will return them to we will return the tensor versions of them also. Tensor self the targets, and we will give it index. We will give it data type of torch.float. Finally, we return it. As last, we define the length. We don't take any parameters for this, and we can just return the length of the targets. Okay, let's check if this works. Let's say dataset. Forgot this. And last, we give the tokenizer. We have an error. X curved. We type it wrong. Let's go here and let's just copy it from here. Okay. Okay, we should make them lists and give it like that to a list. Okay. Now let's print the length of the dataset. And let's try to print the length of the actual data frame. And they should match. Okay, they are matching, so we are doing correctly. And let's just try to take an example from the dataset. Let's say 0. And error in here, this is supposed to be encodings, not encoding. Rerun the dataset. Rerun the lengths, and this name is okay, another typo. This is not value, but just val. Okay. Yeah, we can see the input IDs. We will have token type IDs, we have attention mask, and these are output of the tokenizer. And additionally, we added the targets. So everything is fine for this. Let's delete these cells. This can stay. Now we will implement a data set for the submission and the testing, which won't have the target. Let's give it complexity, submit dataset. Let's give it dataset. Let's give it init, self, sentences, tokenizer, and IDs. We will assign the IDs to IDs. What's different from the previous dataset is that we took the IDs as the argument and we didn't take the targets. And again, we will do encodings, tokenizer, sentences, padding, true, truncation, true, max length equals the max length. It's time for the get item. We'll give self and we will take an index. Again, we will define the outtick. We make the values torch, tensor, value, index, for key, val in self.encodings.item. Okay, we add IDs to outtick. We give self IDs index, whatever ID we are at. Lastly, we will have length. We give self. We return length of the IDs. Okay, now let's try this. Let's create test dataset. Complexity, submit dataset, test data frame, export to list. We give tokenizer and we give test data frame ID to list. Now let's print the tests, length of tests data set, and let's print the length of the test data frame. Okay, there we go. So we are doing it right. Let's test the get item function. We got an error about item. It says there's a key error. We forgot to return it. This has to be items, not item. Let's rerun it. Let's rerun this, and yeah, we have IDs additionally, and the rest is returned by the tokenizer. Let's remove this. Let's take these into one cell. After that, we have to split the train into train and validation. So we are going to define a generator. Torch.generator. We will give it manual seed of 42. We will be returned by train dataset, validation dataset. We will use random split we imported earlier. We give the datasets and we give the ratios that we wanted to be splitted. We want 0.9 to be train and 0.1 to be validation. And we pass the generator. And typo generator. Okay, now we will define our data loaders. For train, let's create train data loader. We will iterate through these during the training phase. Data loader dataset equals to train dataset. Batch size equal to batch size. And we want to shuffle this. And we'll create a validation data loader. Again, data loader. Dataset as well. Dataset. We have the batch size of batch size we defined earlier. We will shuffle this too. Now we have the test data loader. Okay, data loader dataset equals the test dataset. Batch size is batch size. And we won't shuffle it, we want it to stay the same. Since it is for our test. Since we will submit it to test. Let's run these. Now we can move to the training part. We have our data ready, we have our data loaders. We will do the training. For that, let's first create our optimizer. We create it from Optim and we will use ADV. As arguments, we will give parameters. We will give learning rate. If you want, we can track the time, I will. We put time at default timer. We'll start the timer and we will iterate through the epochs. To track that, I put it inside TQDM. I will give position 0 and leave true to TQDM so that it won't print a new line. We put the model into train mode here and we store the losses here. First is 0, of course. Let's start the first training loop. We will have index and we will have the sample in. We'll enumerate the data loader, train data loader. Again, the same arguments, position equals to 0 and leave equals to true. From that, we will take input IDs from the sample and we will put it to device. We will take attention mask. We will put it to device. We will take the targets. We will put it to device. All these come from this dataset. Remember, we just print a sample index from this dataset. This dictionary contains the input IDs, attention, mask, and the targets. We assign the targets here, and the rest is just the output of this tokenizer. Since we have all these, we can give this into the model. For input IDs, we will just pass input IDs or attention, mask, we pass attention, mask, and for the labels, we pass targets. This model automatically returns us the loss value, so we don't have to define an additional loss function. We can take it with this. Can take the loss like this. After that, we have to make sure the training is happening. So we will go backward and we will optimize the step. And lastly, we will update the loss. We can take the loss like this. Let's update the final train loss. Train running loss, we divide it by index plus 1. Now we will need the validation. We will print the validation loss scores too. For this, let's put the model into evaluation mode first. We will have the train running loss equals to 0. Again, the same procedure. We started with 0. With torch.noGrad, we have to give this. It makes sure that there's no gradient update, no learning, no wasted resources computation whatsoever. We are here for the evaluation now. Again, for index and sample and enumerate. Again, we are in TQDM. This time we will iterate through the validation Dataloader. We will give it position 0 and we will leave true. Okay. Now we are iterating the validation Dataloader. Again, input ID, sample, input IDs. We put it to device. Attention, mask from the sample, and attention, mask. We put it to device. Targets, we take it from the sample. We put it to device. And we feed everything to the model. Input IDs, just the input IDs. Attention mask equals the attention mask, and labels equals the targets. Let's update the loss, validation loss. Learning loss plus equals the outputs loss that item. Let's take this one step up, and we will have validation loss, the final validation loss, divided to index plus 1. Since this is done, let's just print the end of the epoch results. To make it pretty, let's put this and 30 of those. Print train loss epoch. Print the epoch number and the loss values. Train loss, let's just print the 4 digits. We will take the same. We will do for validation. Valid loss, epoch plus 1. We will print the val loss. We will close it with this. For the timer, as you remember, we started a timer. Let's stop this. Time it. That's default timer. Let's print the training time. Stop minus start. Let's just print the 2-digit seconds. This is a training loop. Let's actually start it. As you can see, it is training. And we can see the GPU utility here. We are using 10 gigabytes of 15.9 gigabyte. Do this, and when the training is complete, let's meet you again. We got an error here. We did a typo. Where is it? This is validation data load. Validation data loader. Okay. Rerun it. Now our training is complete. Let's look at the losses. What's important here is the validation loss. Actually, the validation loss increased in the second epoch. That is something that we don't want. In this case, we're supposed to take the first epoch model. For simplicity, let's just continue with this, okay? What is left to do is do the predictions for the test data frame and put it into a submission file and submit it. For that, first we have to empty the CUDA so that we will have some GPU left. So we can do that with empty cache. Okay. We will store the predictions in a one list and the corresponding IDs in another list. We take the model to evaluation mode. Again, we will do with the torch no grad since we don't want any gradient updates or something like that. We will iterate through test data loader this time. Again, position is 0 and leave true. Input IDs, sample, input IDs. We put it to device. Attention mask, sample, attention mask, we put it to device. IDs, we will update our IDs list, we will extend it. Sample, IDs, we won't put it to device, we want it to stay in the CPU since we are not going to pass it to the model. And let's take the outputs. Model input IDs equals the input IDs. Attention mask equals the attention mask. And let's put them into the preds list. Preds extend. They are in torch format. We want them to be in the float format for I in outputs. Logits. We want to squeeze them because they have an additional dimension. We don't want that. So we just squeeze that. And that's it for prediction. Let's run this. For this specific case, we have only 7 examples, so it's just super fast. Let's prepare our submission data frame. For that, we will create pandas data frame. We will zip those two IDs and preds. We will name the columns as ID and target. We can see it here at the sample submission. ID, target, IDs, and target values that we found. Lastly, we want to save it as a CSV file. To CSV submission.csv, and we have to set the index false. This has to be columns. Okay, since this is done, we are ready to submit it. For this, let's put this here. For that, we go here and we click submit. Version 1, let's say submit, and it is queued. Okay. When this is done, let's meet here again. Now our training is complete. Let's look at the losses. What is important here is the validation loss. Actually, the validation loss increased in the second epoch. That is something that we don't want. In this case, we supposed to take the first epoch model. But for simplicity, let's just continue with this, okay? What is left to do is do the predictions for the test data frame and put it into a submission file and submit it. For that, first we have to empty the CUDA so that we will have some GPU left. We can do that with empty cache. Okay. We will store the predictions in a one list and the corresponding IDs in another list. We take the model to evaluation mode. Again, we will do with the torch no grad since we don't want any gradient updates or something like that. We will iterate through test Dataloader this time. Again, position is 0 and leave true. Input IDs, sample, input IDs. We put it to device. Attention mask, sample, attention mask, we put it to device. IDs, we will update our IDs list, we will extend it. Sample, IDs, we won't put it to device, we want it to stay in the CPU since we are not going to pass it to the model. And let's take the outputs. Model input IDs equals the input IDs. Attention mask equals the attention mask. And let's put them into the preds list. Preds extend. They are in torch format. We want them to be in the float format for I in outputs. Logits. We want to squeeze them because they have an additional dimension. We don't want that. So we just squeeze that. And that's it for prediction. Let's run this. For this specific case, we have only 7 examples, so it's just super fast. Let's prepare our submission data frame. For that, we will create pandas data frame. We will zip those two IDs and preds. We will name the columns as ID and target. We can see it here at the sample submission. ID, target, IDs, and target values that we found. Lastly, we want to save it as a CSV file. To CSV submission.csv, and we have to set the index false. This has to be columns. Okay, since this is done, we are ready to submit it. For this, let's put this here. For that, we go here and we click submit. Version 1, let's say submit, and it is queued. Okay. When this is done, let's meet here again. Now our submission is completed. You can see the notebook run is done and submission is complete. We can just click here to see the final results of your model. This is your private score, this is your public score. If you want to make your notebook public and share it with everyone, you can come here and say share and make it public. I will share this notebook to you in the description. And that's all for today. Thank you for listening.